Jungle.
Let's jump back to logic gates. Here's the OR gate. Here's how you remember how this gate works. The output is true if input A or input B is true. What this means is that either one of the inputs must be true for the output to be true. Using this rule, let us construct the truth table for the OR gate. First, we populate the input side using the methods we just went through. Now, let's compare the two inputs using the OR gate rule. If both inputs are 0, neither input is true, hence the output is false. If the first input is true, the rule is fulfilled. The output is true. Same goes if the second input is true, the rule is fulfilled as well, and the output is also true. Now when both inputs are true, does it also mean that at least one of the two inputs are true? Well, yes. Hence, the output is still true. This truth table is characteristic of the OR gate. Learn to recognize this table. You'll need it. Now for the AND gate. If you understood the OR gate well enough, you can probably figure out the AND gate's general rule. For the output to be true, input A and input B must be true. That essentially means both inputs must be true for the output to be true. So let's create a truth table based on that rule. 2 zeros, definitely false. If only one of the inputs are true, that won't do either. The output is still false. 2 ones. Since both inputs are true, the output is true as well. This truth table you see here is characteristic of the AND gate.
Okay, now we'll be talking about Boolean theorems, the 70 Boolean theorems that can help to simplify logic expressions. So the first theorem states that when x is multiplied with 0, the output will be 0. The second theorem states that when x is multiplied with 1, the output will be x.
Theorem 3 states that when x multiplied with x, the output will be x. And Theorem 4 states that when x multiplied with not x, the output will be 0.
Starting from Theorem 5, the theorems following this will involve addition. As you can see, in Theorem 5, x added with 0 is equal to x. And Theorem 6 states that when x is added with 1, 1 will be the output.
Theorem 7 states that when x added with x, the output will be x. And Theorem 8 states that when x is added with not x, it equals to 1.
Now we'll be talking about multivariable theorems. The first involves commutative laws. In commutative laws, there are 2 theorems. So, Theorem 9 states that when x is added with y, the output will be the same as y added with x. So, in Theorem 10, is also the same. So, the output of x multiplied with y will be the same as the output of y multiplied with x. Next is associative laws. So in associative laws, Theorem 11 states that the output of x added with the addition of y and z inside a parenthesis will be the same as the output of x added with y inside parenthesis plus with z. These outputs will also be the same as the addition of x, y, and z. Now Theorem 12 states that the product of x with the product of y and z inside a parenthesis is equal to the product of x and y inside a parenthesis with z, which is also equal to the product of x, y, and z. Next is distributive law. In Theorem 13a, it is stated that when x is multiplied with the sum of y and z inside a parenthesis will be the same as the output of the product of x, y added with the product of x and z. In theorem 13b, it is stated that when the addition of w and x inside a parenthesis is multiplied with the addition of y and z also inside a parenthesis, will produce the output that is equal to the addition of the product of w and y with the product of x and y with the product of w and z, and also with the product of z and x.
The 14th theorem states that when x is added with the product of x and y, it equals to x. Theorem 15a states that when x is added with the product of not x multiplied with y, it is equals to x plus y. Theorem 15b states that not x added with the product of x and y is equals to not x plus y.
And now the last two theorems are under De Morgan's theorem. So, theorem 16 states that the inversion of the sum of x and y is equal to the inverted value of x multiplied with not y. Theorem 17 states that the product of x and y that is inverted is the same as not x plus not y. And thus end our explanation of the Boolean theorems that help to simplify logic expression.